In this video, I'd like to introduce the idea of a relation. So let's start by talking about sets. So a key fact about a set is that there is no order to the elements of a set. So for example, consider this set here consisting of two elements A and B. Now notice that set is exactly the same set as what's depicted here, in which we write it as B, A. Both of these descriptions of the set indicate the exact same set, namely a set consisting of two elements, A and B. But often we need to indicate a relationship between two elements. And when we do that, we need to use something other than a set, something other than these curly braces to indicate that it's a set. So what we typically do there is we use what's called an ordered pair. So an ordered pair are two elements listed inside of parentheses, between two parentheses. So the ordered pair A, B typically means that A is related to B in some way. Okay, and so an ordered pair is just a listing of two elements. So it looks very much like a set where you list the element separated by a comma, but you're using parentheses instead of curly braces. So that indicates we're talking about an ordered pair. Now a relation is simply a set of ordered pairs. So let's look at an example. Suppose we have a set of four students, Anne, Bob, Carla, and David. And we have a set of three discussion sections, Friday at 10 a.m., Friday at noon, and Friday at 1 p.m. Now consider this following relation. So the relation R is going to be a set. So the curly braces there indicates that a relation is in fact a set. The elements of a set are going to be the ordered pairs, the things that are related to each other. So this relation has four elements, so that is four ordered pairs, indicating which students are enrolled in which discussion sections. So for example, the ordered pair Anne, Friday at 10 a.m., this is an element of R. That means that Anne is enrolled in the discussion section that meets Fridays at 10 a.m. Now, often we want to be able to display or visualize a relation, because just looking at a set of ordered pairs, you can't get it. It's sometimes hard to visualize or understand what's going on in this relation. So in order to visualize this relation, what we're going to do is we're going to write down all the elements, all the students, so all the elements on the left-hand side of the ordered pairs, and all the elements on the right-hand side of the ordered pairs, namely the discussion sections. And now we're going to draw an arrow from a student to a discussion section to indicate that that pair is an element of the relation. So this arrow means that Anne is related to Friday at 10 a.m. That is an element of the relation R. So we can quickly see that there are two students enrolled in the Friday at 10 a.m. discussion section, and Carla and David are each in the other discussion section. Carla's in the Friday at 1 p.m. Section, and David's in the noon section. Now, so that's a nice way to visualize a relation, but often relations are going to be defined on a single set rather than as being defined between two different sets. So the example we just gave, we were talking about a relationship between two completely different sets of objects. You had on the one hand students, and then on the other hand discussion sections. So for example, consider the relation is greater than on the set 1, 2, 3 of numbers. Okay, so this to write down what that relation is, it's going to be a set of ordered pairs. So each ordered pair is going to be a number from this set and another number from this set, and they have to stand in the relationship that the first number is greater than the second number. So 3 is greater than 2, 3 is greater than 1, and 2 is greater than 1. So that's the greater than relationship, or the greater than relation, on this set, on this single set 1, 2, 3. Now, if we want to visualize it, we can do it exactly the way we just saw. We write down this set, the set of things that appear on the left-hand side of your ordered pairs, and then you rewrite the set. You reproduce the set that because it also appears on the right-hand side of the ordered pairs. And then we draw an arrow, for example, from 3 to 2 because 3 is greater than 2 and 3 is greater than 1, and so on. But this is a bit cumbersome because notice we are rewriting the exact same elements twice, both on the left-hand side and on the right-hand side. So typically what we're going to do is we're just going to draw a single diagram where we just write the numbers down once. So you have 3, 2, and 1, those are the numbers. And then we draw an arrow from 3 to 2 to indicate, just like we did before, that 3 stands in the relationship of being greater than 2. So this means that 3 is greater than 2. This arrow means that 3 is greater than 1. And then finally, this arrow means that 2 is greater than 1. So to summarize, an ordered pair is a sequence of two elements in which the order matters. So for instance, the ordered pair AB is different. It represents a different relationship than the ordered pair BA. And we write AB is an element of R. You can take that to mean that A is related to B according to the relation R. Okay, so A is related to B according to the relation R. That's what we mean when we say that AB is an element of R. Now, rather than writing AB as an element of R, we sometimes use what's called infix notation, and we write that A is related to B, and this just simply indicates that this pair, AB, the ordered pair AB, is an element of R. And in fact, this is what you're used to with the greater than relation, because you would write, rather than saying 3, 2 is an element of the greater than relation, what you would do is you would write 3 is actually greater than 2. But these two notations really mean exactly the same thing, namely that the ordered pair 3, 2 is intended to represent a relationship of is greater than between numbers. And then finally, we visualize when a pair AB is an element of a relation, or equivalently A is related to B, by drawing an arrow from A to B. So that's the way we are going to visualize relations.